Hey everybody, welcome back to Quantitative Reasoning. Today we are in Chapter 11. We're doing Section 11.1, which is all about the fundamental accounting principle. This one is a really simple one. This will be a really short video compared to the ones we've done before. So let's go ahead and look at today's objective, which is just use the fundamental accounting principle to determine the number of possible outcomes in a given situation. So here's the fundamental accounting principle. The number of ways in which a series of successive things can occur is found by multiplying the ways in which each individual thing can occur. One way you can see this is by drawing a tree diagram to represent all of the possible choices. So here is a tree diagram. We've got a fellow who's trying to decide what outfit to wear for the day. He has a choice of 2 different pairs of pants, and then he has a choice of 3 different shirts. So notice that whether he chooses the blue or the black pants, his choice of shirts is the same 3 shirts. So this tree diagram shows that there are 2 times 3 different outfits that he can make from 2 pairs of jeans and 3 t-shirts. And since 2 times 3 is 6, there are 6 different outfits that he can make out of 2 different pairs of jeans and 3 different t-shirts. So here is our first example. Example 1 says, a restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? So what we're going to do is put down a blank for each event that's going to occur. So in this case, the person is going to order 1 appetizer and 1 main course. So I need a blank for the number of appetizer choices, and that's going to be multiplied by the number of main course choices. So there are 6 appetizers and 14 main courses to choose from. 6 times 14 is 84. So there are 84 different combinations that a person could order when they're ordering a 2-course meal at this restaurant. And here's example 2. It says next semester you are planning to take 4 courses: math, English, biology, and humanities. Based on time blocks and highly recommended professors, there are 5 sections of math, 3 of English, 2 of biology, and 4 of humanities that you find suitable. Assuming no scheduling conflicts, how many different 4-course schedules are possible? Okay, so again, we need a blank for each course that we're going to choose, and we're choosing 4 courses here. So I need a blank for my math choices, a blank for my English choices, a blank for biology choices, and humanities choices. Now there are 5 sections of math that we can work with, 3 sections of English, 2 sections of biology, and 4 sections of humanities. And so if we multiply all of these choices together, 5 times 3 times 2 times 4 gives us a total of 120 different 4-course schedules that we could make based on these choices. And here's example 3. A pizza can be ordered with 2 choices of size, medium or large, 3 choices of crust, thin, thick, or regular, and 5 choices of toppings, ground beef, sausage, pepperoni, bacon, or mushrooms. How many different 1-topping pizzas can be ordered? Okay, so we have 3 different things that we're choosing, right? We have to choose the size, the crust, and the toppings. So we need to put down 3 blanks. We have 2 choices of size, we have 3 different choices of crust, and we have 5 different choices for the toppings. So 2 times 3 is 6, and 6 times 5 is 30. So there are 30 different 1-topping pizzas that could be ordered based on this setup. And example 4. Car manufacturers are now experimenting with lightweight 3-wheel cars designed for 1 person and considered ideal for city driving. Suppose you could order such a car with a choice of 9 possible colors, with or without air conditioning, electric or gas powered, and with or without onboard computer. How many ways can this car be ordered with regard to these options? Okay, so we need a blank for each choice that we have to make. We're going to be choosing the colors, whether the car has air conditioning, whether it's electric or gas powered, and whether it has an onboard computer. So that's 4 different things, so we'll need 4 blanks. Okay, they told us that there are 9 color choices. so we put 9 in the first blank. For air conditioning, there are 2 choices, with or without, so we put 2 in the blank. For the power source, it's either electric or gas, so that's 2 choices. And for the computer, it's either with or without, so that's 2 choices. And so now 9 times 2 times 2 times 2 is going to be 72 different ways that we could order this car with regard to these options. And example 5. You are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many different ways can you answer the questions? Okay, so again, we need a blank for each thing that we're choosing, and we are choosing the answer to 10 different questions, so we need 10 blanks. Now, for each question, there are 4 choices. So there are 4 different ways that we could choose to answer question 1, 4 different ways that we could choose to answer question 2, and so on, 4 choices for each question. And of course, we don't want to type 4 times 4 times 4 10 times into our calculator. So what we want to do before we grab the calculator is write this in exponential form. There are 10 4s being multiplied together here. The better way to write this is to say 4 to the 10th power. And then if you enter it in your calculator that way, 4 to the 10th power is equal to 1,048,576. And here's example 6. And this one is so similar to the previous one that if you would like to try it on your own, I think that's a great idea. Let's go through it together now. You're taking a multiple choice test that has 6 questions. Each of the questions has 3 answer choices with 1 correct answer per question. If you select one of these 3 choices for each question and leave nothing blank, in how many ways can you answer the questions? Okay, we need a blank for each thing that we're choosing, and we're choosing an answer to each of the 6 questions. There are 3 choices for each question, so I'm going to have a 3 in each blank. There are 1, 2, 3, 4, 5, 6 3's being multiplied together here. So that is 3 to the 6th power, and that comes out to 729. Here's example 7. Telephone numbers in the United States begin with 3-digit area codes followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with a 0 or a 1. How many different telephone numbers are possible? Okay, so if we're going to choose digits for a phone number, we need a blank for each digit. The area code is 3 digits, and then the local telephone number is 7 digits. So we need a blank for each of those. That's 10 blanks total. Now, for the area code and the local telephone number, we have to make sure that they don't start with 0 or 1. So there are 10 total digits, but this digit can't be 0 or 1. So for this first digit, there are only 8 choices. This first digit could be a 2, 3, 4, 5, 6, 7, 8, or 9. That's only 8 different choices for the first digit. There are 10 different digits that this second digit can be, 0 through 9. So that's 10 different choices. And then 10 different choices for the third digit. Now for the fourth digit, we are to the beginning of the local telephone number, and again, that cannot start with a 0 or a 1, so there are only 8 different digits that could be chosen for this blank, and then there are 10 choices for each remaining digit. Okay, so what we're going to do, instead of typing these individually into our calculator, is we're going to take advantage of exponential notation again. So there are 2 8's, so I'm going to write 8 to the 2nd power, and that's going to be multiplied by 10 to the 1, 2, 3, 4, 5, 6, 7th, 8th power. So 8 to the 2nd power times 10 to the 8th power, and that's what you enter into your calculator, and we'll come out with 6,400,000,000 different telephone numbers that are possible with this arrangement. And let's get one last example together. This is example 8, and it says an electronic gate can be opened by entering 5 digits on a keypad containing the digits 0 through 9. How many different keypad sequences are possible if the digit 0 cannot be used as the first digit. Okay, so we need to choose a digit for 5 different digits in our code, so we'll need 5 blanks. Now remember that the first digit cannot be a 0. So if 0's out, that leaves 9 choices for the first digit, but then the rest of the digits can be anything 0 through 9, so that's 10 different choices for each remaining digit. So we have here 9 times 10 to the 4th power, which is 90,000. Okay, you guys, that one was pretty fast and pretty simple. So I hope that you've enjoyed this section and that the homework will go smoothly for you. And I'll catch you again in the next video for section 11.4. Bye now.